To do blind solving, and I'll start with the 2x2, it's interesting to me that one doesn't have to memorize the position of everything as everything moves. I had thought that if I, for example, rotated this, I would have to memorize where this position, this cube was before, where it is now, where this one was, where it is now, where this one is, where it was now, etc. And after one move, it's not that hard. But if I move a couple, my brain can't think that far ahead. So what's interesting in this is you basically do swapping. So there will be a piece that is called the buffer position, and I'm using the Old Pochmann method. So however I have the cube oriented, the buffer position for me will be this sticker. Not this piece, because it could be oriented anyway, but this piece. And I have an algorithm that will swap it with this piece, which I'll call the target location. So for example, let me start with a solved cube. Okay, I'm starting with a solved cube, and many people use the World Cubing Association orientation for scrambles, which is with white on top and green at the front. And that's also how they solve it. So they always know, blindfolded, which sides are where. The first thing to do is use a lettering scheme. Many people use the Speffz scheme, which uses alpha characters for each sticker position. On each face, they're lettered in a clockwise direction, starting with the top. So this would be A, B, C, D. Then it moves over to the left side, E, F, G, H. Then the front, I, J, K, L. To the right, M, N, O, P. Then to the back, Q, R, S, T. And then return with green in front, and on the bottom, U, V, W, X. So the Old Pochmann method I use with the flipping algorithm flips this position, which is E, this sticker, so it's orange, on the white, blue, and orange piece, and it will swap it with this position, which is V. So this is the yellow, green, and red. So the algorithm is R, U prime, R prime, U prime, R, U, R prime, F prime, R, U, R prime, U prime, R prime, F, R. I had to learn that and get faster at it. But basically, as you see, it did not disturb any of the other pieces. So these are all still intact, but it swapped this cube with this cube, and specifically, as I mentioned, the sticker that was here, which was orange, is now in that position. So if I do those moves again, it should swap them back. And there they are. So the goal of memorizing for a blind solve is to figure out where each sticker will go, and it's like a chain effect. So you'll see what I mean with a simple little swap. Let me set it up and I'll come right back. So in this particular simple little case, we only have one piece really that's out of place, not counting the buffer position. And what we see is what's in the buffer position here is the yellow of the orange, blue, and yellow. This piece goes down here. This is position X, which will come in handy in a minute when we do longer memorization. But for now, we just need to understand how to swap this with this when we know our algorithm only swaps this with this. So if we move the position that it needs to be swapped to over here to our target position, so that piece is there now. Now we know if we swap that with that, we're off to a good start. So we'll do our swapping algorithm. And then we have to move this piece back. So we moved it from over here, so we move it back. And look, we have swapped it and solved it. So that's the key in how these blind solves work. Let me set up one that has two pieces. Okay, in this example, we have a couple more pieces that are out of place. So we do the same thing that we did last time, but we'll chain some together. So I'll show you what we mean. And this is where we need to remember the letters. So we first look at the buffer position. It's the orange, blue, yellow piece. So we know that goes down here, and the yellow sticker specifically goes under here. We remember that is X. So remember X right now. Then we look at this position, this sticker and this piece. This piece is red, blue, and white, specifically white. That piece goes here, because that's the blue side, the red side, and white. So the white goes up here, which is position B. So we remember X and then B. Now, since this piece, the white, orange, and blue, is the piece that belongs in our buffer position, we don't need to remember a letter for it. So all we need to remember right now is X and B. And we have to do them in order. So as we did before, we want to swap out the piece first with X. X is not over here in our target position, so we need to move it to be there. And if we move this bottom layer 180 degrees, it's now in the buffer, in the target position. So now we do the swapping algorithm. And we move it back to where it was. So it was back over here. And as you'll see, it's actually now in the correct position. We then remembered that the next letter was B. Again, we don't want to swap what's over here in the buffer with the target position because that's not our B. Here's the B. So we need to move the B to there first. The way we do this is if we move it to there, that's not it. If we move it to there, there it is. So that was a 180-degree turn of the right slice. So now we do the swapping algorithm that'll swap that sticker down there. And now that it's swapped, we need to bring this back up to where it was. So we need to reverse the 180-degree turn that we did before. It's now in the right place. And since we only had those two, everything is solved.